Explain the purpose of training, test, and validation sets in machine learning. What is cross validation and how does it differ from simple train validation test split? In machine learning, the available data set is usually divided into three parts: training, validation, and test set. Each of these has a specific role in building and evaluating a model. First is training set. This is the portion of data used to train the model. The algorithm learns patterns, relationships, and structures from this data. In this set, the model learns the pattern and relationships from the data. Validation set. Uh, Example of training set. If you are training a model to predict house prices, the training data helps the model understand how features like size, location, age affect the price. Validation set. The validation set is used to tune model parameters, check how well the model performs on unseen data during training. In validation set, during training, we see that how the model react or perform on the unseen data. This process is performed during training. It helps in model selection, hyperparameter tuning, and avoid overfitting. The model is not directly trained on this set, but its performance on it help adjust setting for better accuracy. In this set, we also work on improvement of the model. Test set. The test set is used after training and validations are completed. It provides an unbiased evaluation of the model's final performance. The test data simulates how the model would perform in real world scenarios on new data. Test set after the training process, the test set is performed that how the model react on the unseen data on the real world problems. Cross validation. Cross validation is a more reliable technique. This is a technique used to evaluate the performance of a machine learning model, especially when the data set is small. इस मेथड में डाटा अलग अलग के सबसेट्स में डिवाइड होता है और एक ही प्रोसेस को हर फोल्ड के साथ implement किया जाता है. In this method, the data is divided into k subsets. The model is trained on k1 folds on and tested on the remaining one fold. This process is repeated k times and each fold gets to be the test set once. The final performance is calculated by taking average accuracy of all the folds. Example, in 5-fold cross validation, the data set is split into 5 parts. The model is trained 5 times. In this data, in this technique, the data set is split into different parts, and the number of parts will be the number on which how many times we will train the model. Each time using 4 parts for training and 1 part for testing. Difference between cross validation and train validation test split. In train validation test split, the data set is divided only once. ट्रेन वेलिडेशन टेस्ट स्प्लिट में जो डाटा है वो सिर्फ 3 पार्ट्स में डिवाइड कर दिया जाता है. एक बार ट्रेनिंग होती है, फिर वेलिडेशन होता है, देन आफ्टर ट्रेनिंग द टेस्टिंग विल परफॉर्म. The model is trained as a single time using the training set. Its parameters are tuned using the validation set, and its final accuracy is checked on the test set. This method is simple and faster, but may not always give reliable results if the data set is small, since the model's performance can depend on how the data was divided. In cross validation, on the other hand, the data is divided into multiple smaller parts that are called folds. The model is trained and tested several times, each time using different folds for training and testing. The average of all these test results give more accurate and dependable estimate of the model's performance. Although cross validation takes more time, it helps in reducing bias and give a better idea of how the model will perform on unseen data. Give the confusion matrix, find classification, accuracy, precision, recall, type 1 error, type 2 error, F1 score, sensitivity, specificity. Explain the importance of precision recall as compared to accuracy with an example. On this data, we will perform or we will find these terms using the formula. True positive is 6, false negative is 4, false positive is 2. True negative is 8. Classification accuracy. We will find the accuracy, and the formula of accuracy is total positive plus total negative upon my total positive plus total negative plus false positive plus false negative. So the accuracy is 0.7. Accuracy means 70%. Precision. Precision formula is total positive upon my total positive plus false positive. The precision is 75%. Recall, it is also called sensitivity or true positive rate. In true positive rate, the true positive rate is always on the upper side, like total positive upon total positive plus false negative. We call is 60%. Type 1 error. This is also called false positive rate. In this, the formula is false positive upon false positive plus true negative. Type 1 error percentage 20%. Type 2 error, formula is false negative upon my false negative plus true positive. Type 2 error percentage is 40%. F1 score. The formula for F1 score is 2 into precision into recall upon precision plus recall. It's 67%. Sensitivity. Sensitivity and recall are the same. Specificity total negative upon total negative plus false positive, so it's 80%. Now we will discuss the importance of precision and recall compared to accuracy. Accuracy alone can be misleading, especially when the data is imbalanced. We majorly use accuracy when the data set is balanced. If the data is imbalanced, then the accuracy can be misleading. Precision tells how many of the predicted positives are actually correct. It is important in cases where false positives are costly. Example, in spam detection, a high precision ensures that important emails are not wrongly marked as spam. Recall tells that how many of the actual positives are correctly identified. It is important where missing a positive case has serious consequences. Its example is in disease diagnosis. High recall ensures that most sick patients are correctly identified. Thus, precision and recall together provide a better understanding of a model's real performance than accuracy alone. Now we will discuss the fifth question. Discuss the importance of dimensionality reduction in machine learning. Compare and contrast feature extraction and feature selection as two approaches to dimensionality reduction and provide examples of techniques used for each approach. In machine learning, dimensionality reduction refers to the process of reducing the number of input variables or features in a dataset while retaining the most important information. To retain the most important information, we usually reduce the number of input variables so that the data can become simplified and faster. As datasets grow larger and more complex, they often contain many redundant or irrelevant features. These unnecessary features can make models more complicated, increase training timing, and sometimes even reduce accuracy, a problem known as curse of dimensionality. So, the curse of dimensionality is basically when, due to a lot of data, the models become more complicated, and it also increase the training timing. Dimensionality reduction also helps in improving मॉडल परफॉर्मेंस. इससे मॉडल का परफॉर्मेंस भी इम्प्रूव होता है क्योंकि इरेलीवेंट और अनयूजफुल डेटा रिड्यूस हो जाता है. रिड्यूसिंग कंप्यूटेशन टाइम सिंस fewer फीचर्स मीन्स फास्टर प्रोग्रामिंग. जितने कम फीचर्स होंगे प्रोग्रामिंग प्रोसेसिंग उतनी फास्ट होगी. Enhancing visualization, making it easier to represent data in 2D or 3D for analysis. Preventing overfitting by simplifying the model and reducing unnecessary complexity. Saving storage space. Fewer features mean less data to store and process. If we if we less the data, then we will have only left data to store. There are two approaches for dimensional reduction. First is feature selection. Feature selection means choosing a subset of the original features that are most relevant to the prediction task. It does not change the data itself, only removes the less important or redundant features. फीचर सिलेक्शन इज बेसिकली जब हम ओरिजिनल फीचर में से कुछ सबसेट निकाल लेते हैं इन विच द मोस्ट important डेटा विल बी included. Now the common techniques are filter methods. Use a statistical test to select important feature. फिल्टर मेथड में हम कुछ स्टेटिस्टिकल टेस्ट लगा के इम्पोर्टेंट फीचर को एक्सट्रैक्ट करते हैं और सबसेट में इंक्लूड करते हैं. एग्जांपल्स आर काई स्क्वायर टेस्ट, इंफॉर्मेशन गेन और कोरिलेशन कोफिशिएंट. Wrapper methods is the second method. In this, we use a predictive model to evaluate different subset of features. Its examples are forward selection, backward elimination, recursive feature elimination. That are the examples. Okay. Third is embedded methods. Perform feature selection as a part of model training. It is treated as the part of training. Examples are lasso regression, decision tree feature importance. Now, its example is in a data set, predicting the house prices. Features like lot size and number of rooms may be selected, while house color may be removed. Uh, then, what is the meaning of house color if we are predicting the price of the house? So, we will simply remove this from the data so that our model will become easy and redundant. Second approach is feature extraction. Feature extraction transforms the existing features into a new set of features that capture the most important information from the original data. Feature extraction में we just extract the features from the original data that are the most important information. Unlike feature selection में हम क्या करते हैं, एक नया फीचर क्रिएट करते हैं एग्जिस्टिंग वन के फीचर्स को कंबाइन और ट्रांसफॉर्म करके. बट इसमें फीचर जो रहते हैं वो एग्जिस्टिंग होते हैं. वी जस्ट सिंपली एक्सट्रैक्ट द मोस्ट इंपॉर्टेंट इन्फॉर्मेशन. कॉमन टेक्निक्स. प्रिंसिपल कंपोनेंट एनालिसिस, PCA, converts the correlated features into a smaller number of uncorrelated principal components. This is the first technique. Now the second is linear discriminant analysis. It reduces dimension by maximizing class separability. Autoencoders are neural networks that compress data into lower dimensional representation. Example is in image recognition, PCA can reduce thousands of pixel values into few principal components that still capture the main image patterns. Now we will just compare the feature extraction and feature selection. Both are the approaches or we can say technique that are used in dimensionality reduction, but they work in different ways. Feature selection means choosing only the most important and relevant information from the existing dataset. In selection, we usually take the important and relevant feature from the existing data. Not We are not taking a subset and combining and transforming the data. We are just taking the important and relevant features from the data. It removes unnecessary or less useful data while keeping the original features unchanged. We are not changing the original features. We are just taking less useful data out. This helps in reducing noise and improving model performance without altering the meaning of the data. For example, methods like chi-square test, information gain, and recursive feature elimination are used for feature selection. On the other hand, feature extraction create new features by transforming or combining the existing ones. Instead of just selecting, it changes the data into new form with fewer dimensions but still retains most of the important information. This approach is more complex but can capture hidden parts in data. Example include principal component analysis (PCA) and linear discriminant analysis, that is LDA. In short, feature selection keeps some of the original features while feature extraction builds new ones from the old feature. Both helps in reducing dimensionality, speeding up model training and improving accuracy.